Okay, now I'll talk about the chain rule, which is what we use when we are differentiating a function inside a function. So a function inside a function, for example, let's take the function f of x is equal to sine of e of x, right? You know how to differentiate both of these. And let's say that e of x, which is inside sine, let's say this is equal to u, and the sine of e of x is equal to v. Yes, it's equal to v. So here we cannot differentiate it normally because there is an x inside the sine, so that changes things. Ooh, it went blurry. That changes things. So instead, first I'll show you the proof before telling you the implications of what it means. So if you're differentiating it, we get dy by dx, right? So that's equal to, we have a u over here, so we can say that that's equal to dy by du times du by dx, because then du would cancel out. And what that means is that we can now approach it methodically. So we can say first dy by du. So really this whole thing is actually y. I lied just now, sorry. So if you're doing dy by du, we differentiate this with respect to u. So we treat u inside here as a variable. So then we get cosine of u, right? Because we're differentiating it. But then we get du by dx. So du by dx would be the differential of e to the power of x, which is e to the power of x. So this doesn't only extend for one variable. Sometimes you have more complex stuff. For example, we could have a function that says g of x is equal to is equal to sine of e to the power of 2x. Then once again, now we have to extend it. So the implication of the chain rule is that if you have a function inside of a function, you have to differentiate also the function inside the function and multiply that by the differentiation of the function. Yeah, I know, I made that really confusing there. So in this case, first we look at where x is, and we differentiate that function inside the function, which is 2, right? Differential of 2x is 2, so we got a 2. Then we differentiate this function, this bigger function here, which is e to the power of 2x. So, it's e to the power of u, because we treat this as a variable. So that's e to the power of u. And then we treat this whole thing as another variable, v. And we have sine of v, we differentiate that, we get cosine of v, which is equal to 2 times e to the power of 2x times cosine of e to the power of 2x. And this is a more complex variation of the question. So I hope this makes sense, and thanks for watching.